Hi Chris, thanks for your question. Today we're going to be factoring the expression negative 2x to the fifth minus 2x to the fourth plus 4x cubed. We're going to be factoring this using the distributive property. So the first thing I'm going to look for in my expression is something that looks the same in all of the terms. So I see that all of these share x to the something. So I'm going to start factoring my x's, all of them over here. X to the fifth is equal to, I'm going to break this down into the smallest degree of x times whatever's left. So x to the fifth is equal to x to the third, because that's my smallest degree of x in a term in my expression, times x squared. X to the fourth is equal to x to the third times x, and x to the third is equal to x to the third times 1. So I am now going to remove whatever is shared by all of these terms on the right side of the expression. It looks like x to the third is the shared term here. So I'm going to remove x to the third and put it on the outside, and then I'm going to rewrite my inside expression. The coefficients, the numbers attached to the x terms, just stay the same for now. So I took out x to the third, so I'm going to cross it out, and what's left is x squared. So I'm going to put x squared here, negative 2, x to the fourth factors into cross out x to the third. All we're left with is x, and 4, cross out x to the third, we're just left with 4 times 1, so just 4. So that's one of our first factors. The other thing I notice is when I look at the coefficients, when I look at the terms attached to my x terms, these are all even numbers. So that means they're going to share a factor of 2. So I'm going to repeat the process and factor all of my coefficients. Negative 2 is equal to 2 times negative 1. Negative 2, that's the same. And then 4 is equal to 2 times 2. So I'm now going to remove a 2. Writing the 2 on the outside, I can attach it to the x third. And my coefficients are going to change into whatever is left after I cross out my 2. So crossing out my 2, my negative 2, all I'm left with is a negative 1. So this just becomes negative x squared. This is the same. So repeat the process for our x term. And then 4, if I cross out a 2, all I'm left with is a 2. Okay, so we're left with a quadratic equation here, which may possibly reduce into smaller factors. So to find out if that does, I'm going to factor this quadratic expression. When I'm factoring a quadratic expression, if possible, I always like to have a leading coefficient of 1, which means I don't want anything attached to my x squared term. So I'm just going to pull out this negative that's attached to everything here. And I'm going to rewrite this with a positive, this with a positive, and then this with the negative. So this turns into x squared plus x minus 2. If I redistributed that negative, I would, of course, back up with what I have up here, which is a good way to check if you're factoring something correctly. So let's see if this factors into anything smaller. To do that, I'm going to use a method that I like the best. It's called the star method. I'm just going to draw a star, 2 diagonal lines and a horizontal line. And over here, I'm going to rewrite my quadratic equation. X squared plus x minus 2. Now, There's something called the standard form of a quadratic equation, which I'm sure you're familiar with. It's the form ax squared plus bx plus c. In my star, up here, I'm going to write a times c. Down here, I'm going to write b. Over here, I'm going to write a, and over here, I'm going to write a. So the a term in this quadratic equation is a 1, and the c term is a negative 2. Don't forget that negative. So a times c becomes 1 times negative 2 is negative 2, and b is just a 1 in this case. A is 1, and a is 1. I'm then going to write a table below my star where I have a, c, and a plus c. My goal in doing this is if AC is equal to negative 2, which we have up here, I want to find every factor of negative 2 possible and write them in here and then add them together. And when I add them together, I want them to equal negative 1. When I multiply them together, I want them to be the number on the top, and when I add them together, I want them to be the number on the bottom. So I'm going to start figuring out my factors of negative 2. If I have a negative 2 and a 1, that would multiply to negative 2. Or if I had a negative 1 and a 2, that would also multiply to negative 2. Those are the only factors of negative 2 I can think of off the top of my head. So now I'm going to add these together. And my goal is to find something that adds to 1. So when I add these together, I get a negative 1. That is not equal to 1, so those are not the numbers I want. When I add these together, negative 1 plus 2 is 1, so these are the numbers I want. So what I'm going to do with these is I'm going to take this one, and I'm going to put it up here. And then I'm going to take this one, and I'm going to put it up here. Then I'm going to put an X next to the terms on the right and left side over here on the top. And I'm going to start factoring this. I'm going to get 2 factors since it's a quadratic equation. And what I'm going to write is this is correlated with my first factor. So it's going to become x minus 1. And my second factor, I'm going to look at the right side of the equation, or the star over here. And this is going to be x plus 2. So I can't factor this out anymore. I have some irreducible factors at this point. That means this whole equation, 2x to the 5th, negative 2x to the 5th minus 2x to the 4th plus 4x to the 3rd, factors into negative 2x cubed times x minus 1 times x plus 2. And this will be your final answer. Thank you very much for sending me your question, and I look forward to answering more of your questions with Snap Math in the future.